Well, we're making up a parts list for the DX60 transmitter. We may as well do the same for the VFO.
The Navy announces that Wake Island is probably captured by the enemy. And now it is disclosed that fewer than 400 Marines held Wake Island for at least 14 days against heavy Japanese attacks.
Good day. Welcome back to Mike's Radio Repair and Restoration. You've probably been following the Heathkit series here that we're working on, and we're looking at the HG-10B VFO today. I've made up a list of parts and pieces I need for its matching transmitter, the DX60B. So while we're ordering parts, we may as well go through this and do the initial inspection on this old girl and see if we need to order anything. We'll take a look at the schematic in a minute. Grid block keying is done with a neon light in circuit that when a ground isn't present from a key or a microphone or the keying circuit, a bias voltage will light up the neon bulb and it will provide grid block keying for the oscillator to stop transmitting. It is my understanding that as these neon small bulbs change, apparently they won't strike. The strike voltage gets too high as they get older. I guess the neon bulb gets gassy, so I guess we're going to have to look at that. And some people were talking about putting a 1 meg-ohm resistor to ground in order to cure it. My gut is just putting a new NE2 neon bulb, and so we're going to look at all that stuff, and we'll look at the schematic a little bit and the interesting grid block keying. So with that, case got a couple of small nicks and scratches, nothing serious. The only thing that I do notice, and again I don't think it's anything serious, is it's missing a foot, and when I shake it, I can hear a little nut and washer rolling around where that one foot at the bottom there used to be. Other than that, visually I don't see anything, so the next thing we're going to do is we're going to flip the case off it and have a peek and see what's going on. So we'll be right back in a second when I get the case off it. Well, with the covers off, everything looks good. The chassis is nice and clean, but you would expect it to be for a completely enclosed box. I've taken the tubes out of it here. There's only one I can test. The other one I have to test in circuit, which is the regulator OB2. But the other oscillator tube, a 6H8, is a bit of an odd duck. So we'll see how that goes. Let's flip it over and look at the underside. Okay, everything's nice and clean on the inside here. It looks reasonably well built. Nothing here is going to prevent us from restoring this old girl, although there's not much to restore. But Heathkit really outdid themselves on the engineering when it comes to the gearing and the dial indicator and roller drum. I'm going to set up and show you all that for those of you who've never seen one of these. Just one second. So I don't know if you can see this. I hope you can. But you got a band selector here now. And the roller drum inside changes for the given bands, which is kind of cool. And then you have your frequency marker as a slide rule type of an ordeal. So it's really quite an interesting setup. And this here goes all the way up to 2 meters. I'm guessing that's on harmonics, which is kind of interesting. So they obviously use this VFO for more than the DX60, but it looks rather nice. Let me just see if I can get a close-up of that drum inside. So here you can see the drum in behind the bulbs there. So this is going to light up nice when it gets power. By the way, this does not have a power supply. It's going to get its power from the DX60. But you can see the drum rolls when you turn the band selector knob. Kind of cool. Looking forward to seeing it roll again. So here's the most of the gear train here is to drive the variable capacitor. And of course the dial pointer, kind of nicely done. The nylon gear is in good shape still. The roller drum is dealt with through a dial cord. connected to a pulley here on the band switch. Kind of cool. Alrighty, well, let's have a look at the schematic and see what we're going to need to do. Well, we're looking at the schematic for the VFO here. Nothing really exciting. This is the neon NE2 light bulb or lamp we were talking about. Basically, the transmitter supplies the voltages for it, B plus filament, ground, and negative bias voltage that passes through this neon lamp through the switch, and ultimately it applies a negative bias voltage on pin 7 of that tube. And when you key the transmitter down, it takes away that negative bias so that the tube continue to operate. So the problem people have is when you go key up on the transmitter and the bias voltage is applied, is the neon lamp won't strike, won't relight, won't apply the bias voltage. Hence the VFO continues to generate RF. So that's the only issue that I know. So there's just some resistors here to check, not too many. I don't see anything out of the ordinary. And we have a nice 108 OB2 regulator here that's going to keep the VFO fairly stable. This one, VFO is not too bad. It's better than the VF1, but we'll see how it goes. So I don't think there's anything crazy here. Whoops, slide it right off the screen. We have all the tuned circuits here. Very interesting. But I think what we're going to do next is I'm going to check those tubes. Well, tube, single one. So we'll crack open the tester and see how that goes. Well, here we go with our 6CH8. It's 2 tubes in one, a triode and a pentode. So we're set up to check the triode portion of that tube first. And that looks screaming good. So let's check the pentode portion of that. And that's good as well. So that's nice, not have to buy another tube. That's just dandy. Well, there's not much to do here. So I'm just going to, since we don't have any wax paper capacitors to replace, looks like all good quality stuff. So the only thing that's left to do on the underside here is go through all the resistors and lubricate all the shafts and clean all the switches and whatnot. So I'm going to tear into that now. I'm going to go through the resistors to make sure that everything's okay. Change what needs to be changed, and if there's something I don't have, I can get it on the order sheet to go with the parts for the DX60B. So I'm going to just go through the resistors and I'll be back in a minute. Okay, with all 9 resistors checked, 4 of them were replaced. 2 of them are kind of buried deep in, were a little bit fussy to get to, and the other 2 weren't bad, but the 4 were had drifted pretty good. And oddly enough, 2 of them were part of the neon bulb circuit, the grid block circuit. So maybe that's why people are having troubles, because they went way high, and that would cause that bulb to not fire. But hey, we won't know until we try it. So at this point, the tubes are checked in okay. All of the wafer switches are cleaned. All of the shafts are lubed. Everything is done. We just now, I guess we have to set this one aside until the DX60 is ready, so we can plug it in and try it out. So I guess with that, we're going to wrap this video up. So thanks for tuning in. Please hit the like button, and if you haven't subscribed, please do. We could certainly use the support. So we'll see you again next time.